So what is resistor here? So resistor is a device. It is a device. It is a device. So we are going to represent like this. We are going to represent resistor as a like this. So this is a point A, this is a point B, right? So the current flows from point A to point B. You are going to represent resistor as a R, right? So the voltage drop of the resistor is, that is a V. And you have to concentrate on two things here. Resistor. Resistor, I told you, resistor means it is a device, right? And what is the resistance? Right. Resistance is a property. It denotes its ability to resist the flow of electric current. So what is the resistance? It is the ability to resist the flow of electric current. Right. It is actually measured in ohm. Right. It is measured in ohm. So this is a scientist name. So they have given the scientist name as a ohm. This is the unit of the resistor. You see that any material has some resistance, right? Any material you take, it has some resistance. Even our body has the resistance. So you take any material, it has the resistance. So every material resistance is not same. It is different. It varies resistance material to material. So to find resistance of any material, we have an equation. So that is R is equal to rho L by A. You see that this is a conductor. This is a conductor. This is one conductor. So this conductor, you see that the length of the conductor is L, right? So the conductor cross-sectional area. This is the conductor cross-sectional area. This circular portion, right? So that is, we are going to denote as a right? And this rho is the material with resistivity. Generally we say it is a resistivity of the material. L is what? L is the length of the conductor, this one, and A is cross sectional area of the conductor. So if you know these three parameters, you can easily find resistance of any material, right? So here the resistance is directly proportional to length, and next the resistance is directly proportional to the resistivity, and resistance is indirectly proportional to A. See, if length increases, what happens? Your resistance will increase. If resistivity increases, your resistance will increase, right? If A is small, what happens? Your resistance will increase, right? So here you see that here this is the resistivity. Resistivity means just it is a property to resist the flow of current. So you see that there are three types of conductors. Here there are three types of materials. The first one is conductors, and second one is insulators. Third one is semiconductors. Okay, so the three types of materials we can come across here. One, the conductors, and the insulator, and semiconductor. You see the good conductors. The good conductors are copper, aluminum, right? So it has a low resistivity. The resistivity of material actually changes, right? So while insulator such as mica, paper have high resistivities, you see the table here. So here's the materials. This column actually the material, and this is the resistivity. And these are the metals. These are the materials, right? You see that silver, what is the resistivity? 1.64 to 10 power minus 8. So the resistivity is very low. So this is a conductor, and a copper also a conductor, and aluminum also conductor, right? So this metal's resistivity is very low, right? This resistance is very low compared to this, right? And this aluminum resistivity is low compared to copper resistivity. Now, of course, the gold also a good conductor, right? So then semiconductors, carbon, germanium, silicon are the semiconductors. So their resistivity is higher compared to metals, compared to conductors, right? So now, so this you see that insulators. So what is that? Paper, mica, glass, and teflons. So you see that the resistivity is very high, 10 power 10, 5 into 10 power 11, 10 power 12, 3 into 10 power 12. So resistance is very high, right? So in resistivity is very less in conductors. In insulators is a medium. In in the semiconductors, so the resistivity is a medium. So in insulators, the resistivity is very high. So that's how this resistivity will tell you how the resistivity will resist the flow of current, right? So this resistivity will keep changing. You just see that R is equal to rho L by A. If you take the two conductors, they are the same size. They are same size. See, this is the same size. Length also same. Length also same. This conductor length also same. This conductor cross sectional also same. This conductor cross section area also same. So what happened? What makes difference? The difference is the resistivity. The difference is resistivity, right? The resistivity will make a difference. You just take this silver. What is the silver resistivity? Silver resistivity. Suppose you take this one is the silver, and you take this one is the copper, right? What is the copper resistivity? Copper resistivity is 1.72 into 10 power minus 8. So copper resistance is 1.72 into 10 power minus 8. The silver resistance is 1.64 into 10 power minus 8. So what happened? So though the material size is same, but based on the resistivity, okay, the resistance will change. This is the equation. This is the important equation one should remember, right? Next, so here you see that one more term, the conductance. Conductance means the reciprocal of resistance is called conductance. So what is the conductance? The conductance means the reciprocal of resistance is called conductance. So you see that this is the equation. Conductance is equal to 1 by R. 1 by R is equal to 1 by V. 1 by V. I tell you how you got this. So you know that the Ohm's law. So V is equal to what? V is equal to I into R. Ohm's law. Right. So now what you do? So here you bring it this 1 by R this side, right? Into V is equal to I. So what is this? 1 by R. 1 by R means it is a G into V is equal to I. So I need a G. So G is equal to what? I by V. That's how I got this C. So conductance is equal to I by V. So conductance is a measure of how well an element will conduct electric current. That we should remember. Conductor means what? It measures how well an element will conduct electric current. Right. So what is the unit of this conductance? It's a mho. It's a mho. You just see that what the resistance unit is. Resistance unit is ohm, but conductance unit is mho. Just a reverse. Right? So you just take in a conductor here. The conductor. This is the resistance. It's a A, and this is a B, and this is the I. This is the R. Right. So current passing through. When current passes through the resistor, what happens? So power will dissipate. So in the form of heat, right? When current passes through this resistor, so what happened? So the heat will be generated here. Heat will be generated. So what happened? That heat will be dissipated. That heat cannot be recovered. It is going to be wasted, right? And also one more thing I would like to tell you here: resistor is a static element. It doesn't store any energy. Alright. So here the equation here P is equal to, so we need to calculate the dissipated power in resistance. There is the equation is there: P is equal to V into I. Alright. So P is equal to V into I. So you know by using Ohm's law, so V is equal to I into R. So we substitute in place of V, so IR. So IR into I is equal to what? I into I square into R, right? So you can also write in this form also. These both are same. So you know that P is equal to V into I. So what is it from the Ohm's law? So what we can write? So you just here in this equation there is no current, it's only voltage is there. So what I do, I just eliminate I is equal to what? I is equal to here V by R. Just substitute here. So V into, in place of I I am going to put V by R. So that is V square by R. So there are two formulas. These are the two formulas we can calculate power dissipation. So this is about resistance, right? And again, the resistance are two types. Resistance are two types. So one is linear resistance. One is the linear resistance. Another one is the non-linear resistance, right? So linear resistance means what? You just see the graph here. This is the VA characteristics. This is the VA characteristics, right? So if there is no change in the resistance, right, so you will get this kind of graph. This is the linear graph, right? So that we say that this is the linear resistance. The resistance, there is no change. So when you say non-linear resistance, if the resistance changes, right, the resistance changes, so what happened? That will change due to temperature. So what happened? So you get this kind of graph, right, when you give the voltage and current. So this will change as resistance change. This is a non-linearity behavior. So this is a non-linear resistance. So and the linear resistance again further classified into fixed resistor and variable resistor. See, so mostly in electric circuits, so mostly at diploma level, mostly we are going to use the fixed resistance. The resistor value is a fixed. So in the variable resistance, so you can use in the lab, in your laboratory, the machine's laboratory. So the variable resistance, if you are interested to control a motor, so by changing voltage, right, by varying this variable resistance, we can vary the voltage so that we can control the speed of the motor. Of course, there is a restart. Doing restart also we can vary the resistors and trimmer also, right. This is the fixed resistor. There are many types are there, but for your level, it's it's enough to know only the fixed resistor and variable resistor, and this potentiometer and restart. That's enough if you know this four resistors, right. So once again I tell you the resistors are two types. One is the linear resistance, another one is the non-linear resistance. The linear resistance means here the temperature is the resistor temperature is a constant, so that it will have the linear graph. If resistor changes, so it doesn't follow the linearity, so we say that is a non-linear resistance, right. So the linear resistance has again classified into two types. One is the fixed resistor, another one is the variable resistance. So variable resistor is a potentiometer, okay, and the resistor, right. So this is enough to, for the diploma level, this is enough to know. I have to know till this. right? So you all you come across this all devices, right? You come across all these devices. So the next slide. Here you see that the resistors. So what you understand here, the resistor will resist the flow of current, right? It resists the flow of current. But you should understand. Okay. Suppose you see that here there is a battery here. It's not connected. You just think this is a 12-volt battery. Otherwise, I will draw it this side. So this is a battery. Of course, this is a LED bulb. This is a small LED. This is small LED. Okay. So this LED has some resistance. Okay. Right. So this is a supply voltage. If I give it 12 volts, right? If I give 12 volts, what happens? If you give 12 volts to this LED, the LED may not handle the voltage which you are applying to this LED, right? So what happens? It will destroy. When you supply high voltage, so this will burn. So this will destroy, right? So what happens? To limit the current, right? So if we give the high voltage, to happen, the high current will passes through this LED, so it will damage, right? So to limit the current, so what I do, I just add one resistor. Suppose because of 12 volts, for example, if it is going 3 ampere, right? So the 3 ampere if we send to this LED, it cannot handle it, right? So if we just if we put 100 kg weight on you, you may not able to carry this. Alright, if I just give 10 kgs, you are able to carry it, right? So instead of giving 3, so what I do, if LEDs can handle only 1 ampere, what I do, by connecting a resistor, so I can only send 1 ampere. So what happens, 2 ampere will be resisted by this resistance. That's how I can save this element, and also I can use for work, right? So here one circuit is given. This is one circuit is given. In circuit you are interested to find resistor. What is the resistor and what is the power dissipation in the circuit, right? So supply voltage is a 10 volt and the current is here already is given. It is a 2 ampere. And what is the resistance value, right? And what is the power dissipation, right? When current flows through this resistor will dissipate the power. So you have to find the resistor. How are you going to find it? Simply by using the Ohm's law. By using Ohm's law, we can find it. What is Ohm's law? V is equal to I into R. So already the current is given, already voltage is given, that is a 10 volt, and your I is a 2, then R. So what is then R? 10 by 2. 10 by 2 is a R. So what happened here? 5. So your R is equal to 5 ohm. So here R is equal to 5 ohms. So in the resistor you are going to connect 5 ohm resistor, right? So, and what is the power dissipation? Power dissipation, you have two formulas. So this is the power dissipation. So I'm just going to write it here. P is equal to V into I. So you can substitute. So V is equal to IR. So P is equal to, so I'm going to write here P is equal to V into I, right? So your Ohm's law says that V is equal to I into R, right? You will substitute here in place of V, I substitute I into R, so you will get, so IR into I. So what happens? This is I square into R. So you got a formula. What is the formula here? I am going to write it here. P is equal to I square into R. So you need to calculate power dissipation the resistor, right? So what is the I? I is equal to 2 amps, that is the square. So what is here? R how much? 5. So 4 into 5 is equal to what? 20. So this is a 20 watts. So power dissipation how much? Here 20 watts. This much power is wasted in this circuit. Right. So this is one of the applications. See, you have seen the resistance, right? You have seen the resistance. So how we are going to calculate this resistance value, right? How this we are going to calculate this resistor? Well, you see that resistor only you see that only is a color code. Which is a color code like this. Some bands are there like this. Some bands are there, but resistance value, the value is not given here. So you have to find it. So how we can find it? You can by using digital multimeter. By using digital multimeter, you can find the resistance value. You can find the resistor value. So how are you going to find it? You just see that this is the digital. This is the digital multimeter. This is the digital multimeter. So you just see that here from here, this is a beep. It's a beep now. This is a beep, and here, so you just check the connectivity of any conductor. Suppose this is a conductor. This is a conductor. Of course, this conductor is covered by insulator. That is any insulating material. Right? You have seen white, right? So inside the conductor, the copper wire is there, and the copper wire is covered by insulator. Right? So sometimes what happens? Maybe some breakage happen. Maybe some breakage happen. Right? So that can be found by checking this continuity. So you just put this knob here, bring it here, okay, and what is the two here as a two points are there. Just here one connect and here this one connect. Right? So what happens? The beep sound will come. So it means there is no breakage. If beep sound not coming means somewhere it's broken, right? Inside the wire, the copper wire is broken. It means there is no continuity, right? So it doesn't make a beep sound, right? You see, we are discussing about a resistance, how to find the resistance value. You see that here 200 ohm, 1 to 200 ohm to 20 mega, right? So you just connect like this, alright. So you just connect this and this point, just to touch it, so it can display the resistance value, right? Resistance value can be displayed here. So what is another method to find? Another method to find is a color code. Another method is to find the color code. So this is one resistor. So I want to find the resistance. See. In this fixed resistor, this is a fixed resistor here. So what happened? The resistance value is not given, but you have to find it. How you can find? By using this color code, resistor color code method. Okay. So by using this, we can find it. So you see that this resistor, I am interested to find the resistance value. You see that here the colors you see. Here is a black, here is a black, this is a brown, this is a red, this is a orange, this is yellow, this is a green, this is blue, this is a violet, okay, and this is a gray and this is a white. Right? These are the colors. These are the colors. How we are going to remember this, I will tell you. So black means it's a 0. Okay. So sorry, black means 0, and brown means 1, red means 2, orange means 3, yellow means 4, green means 5. Alright, and blue means 6, violet means 7, green means 8, and white means 9. White means 9. You see that here, yes, here you see that here. You're seeing this resistance here. So you see that the gold, the tolerance. So tolerance will change here. The tolerance here, gold is a 5%, and the silver is a 10 percentage, and none is a 20%. I will explain this one. For example, you take this resistance. I want to find the resistance of this value. So what happened? How many bands are here? So there are 1, 2, 3, 4 bands are there. There are 4 bands. Besides this, here we only consider these are the 3 bands. The final one is this one is the tolerance band. This is the tolerance band. So this is the 3 bands. How we are going to find the 3 bands? So here the first band we can say that is the first digit, and the second band you say that second digit, and the third you say is a multiplier. See, for example, you take this resistance. Of course, this one is the tolerance. This is the tolerance, right? Tolerance, yellow or orange, there's a different tolerances are there. So if you just see that to find this, what is the first blue? What is the blue? It is a 6. It is a 6. First digit is a 6. And what is the second digit? It is a red. What is second digit? It is a 2. What is the third digit? Black. Black means I'm just going to multiply like this, 10 power 0, 10 power 0, right? So this is a 62, 10 power 0 means what? 62 ohm resistor. So since it is a yellow, the tolerance is here 5%. 5%. You say that, let's say this is a considered, this is a gold. This is a gold, and the tolerance is 5%. Tolerance 5%. It means 5% means 0.05. So 0.5 means plus or minus 0.05. So what happened? This resistance between 62 plus 0.05, it is between 62 minus 0.05. So we just calculate it to 62 plus 0.05 ohm. In this range, so the resistance value would be there. This is how we are going to find the resistance value. You just see that here also you take here this resistor. This resistor, how many bands are there? There are 4 bands. This is a 1, 2, 3, 4, 5. There are 5 bands are there, right? So this is the 4 bands we have to consider. This one is the tolerance band. So tolerance band, I told you, generally you are going to get a gold. Gold means 5%. Silver means 10%. Others or 20%. So I am going to find the resistance value of this. So here there are 4 bands are there. Here the 3 bands are there. So what happened? This is the first digit and second digit and third digit, and the last digit you have to multiply. You see that what is the first digit? Red. Red means here 2. First digit is a 2. And again, what is this one? This one is the blue. So blue means here, what is this? It's a 6. It is the 6th second digit. What is the next? Black means it's a 0. This is the third digit. And the fourth one is the orange. Orange means what? You have to multiply 10 power 3. 10 power 3. Orange is 3, so I'm just multiplying 10 power 3 ohm. 10 power 3 ohm. So what is the tolerance? What is tolerance is actually silver is a 10%. 10% tolerance, right? So this we can write 260 10 power 3 means kilo ohm, plus or minus. This is the plus or minus 10%. So this resistance value would be 26 kilo ohm minus 10% to 26 kilo ohm plus 10%. In this range, the resistance value would be there. That's how we are going to find this resistance value, right? By using the color code method. How we are going to remember this color code? So very simple. You should remember BB right. So you can remember. So like this, BB right BB, right? Great Britain, very good, while BB, right? Great Britain, very good, while. That's how we have to remember. So B means here, see here, see here, BB, Roy, Great Britain, very good, while. B means first black, brown, red, orange. Y means yellow. G means green. B means blue. B means violet. And G means gray. And W means white. This is the loss bands. This tolerance band. So it varies plus 5 to minus 5% here. The 5% means here plus or minus 5%. Right. Here the silver means 10%. Other material is 20%. Other resistance. If the band is another color is there. This is how we are going to find the resistance value.